In the diagram, A and B are two ports 15 kilometers apart. B is on bearing 094 degrees from A, and C is a ship on the sea. The ship is seen from A on bearing 150 degrees and from B on bearing 245 degrees. Calculate correct to one decimal place the distance of the ship from A and how far east of A is C. So because we have been provided with a diagram, so we're going to work with this diagram, but this is not the final diagram, so we're going to draw it again and work with information that has been given to us in order to calculate for Roman figure 1 and Roman figure 2. A gives us, this is A, point A, we have point B. Let's see. And 15 kilometers apart. So from A, bearing of B from A is 94 degrees, and then the bearing of so B from A and C, so the ship on the sea, the ship is seen from A on bearing 150 degrees. C is seen from A on bearing 150 degrees. So bearing of C from A is equal to 150 degrees. So 150 degree line connecting A and C is this line. So bearing 150 degrees will be from here to this point. That's 150 degrees. So let me call this angle 150 degrees. Okay, then here says the ship is seen from A on bearing 150 degrees and from B on bearing 245 degrees. From B, C, the bearing of C from B is 245 degrees. 245 degrees. So calculate correct to one decimal place. Okay, so this is everything that was given to us. So let's work with this now. So we need to know this angle. We need to know A. Let's call here A. Let's call here B. Let's call here C. And then we need to know D, and we also need to know E. Let's call here E, and let's call here F. Let's also call here G. Okay, so let's start. Now A is gotten from A is equal to from here. Already know that from this line, the bearing of B from A is 94 degrees. So from the north to this line is 94 degrees. Then from the north to this line is 150 degrees. So to get this to get E, we can say A is equal to A, and so 150 degrees and G, the angles on a straight line. So this is what we have, 150 degrees and G. So G, so A plus okay, not really A plus yeah, A itself. I'm trying to get G. So to get G, I'm going to say G plus 100 and 150 degrees is equal to 180 degrees. Why? Angles on the line. So G is equal to 180 degrees minus 150 degrees. That would be 30 degrees. So G is 30 degrees. So what about A? A is equal to, so our A would be from here to here, from the, so A would give us from here to here is 150 degrees, and from the north to this line is 94 degrees. So this angle alone from here to here, which is A, will give us 150 degrees minus 94 degrees. $56. 56 degrees. Let's come over to this side. So G here is B is equal to G. That's equal to G is what's G? 30 degrees. And Y? Alternate angles. Alternate angles. And we can get, okay, we can still get an angle here. But let me see. Let's go on. Yes, need for that. So F, what is F? F is equal to, what would F be? F. Okay, let's leave F out for now. So B, I've gotten B, I've got now to get C. So for us to get C, let's get D first of all. So angle D is equal to, here, from here to here is 180, and from the north to this line is 45 degrees. So D would be 245 degrees minus 180 degrees. D 245 minus 180, that's 65 degrees. So D is equal to 65 degrees, and C is equal to D equal to 65 degrees. Why? Alternate angles. That's C. Now to E, how can we get E? We can get E by using, okay, so now let's go to E. Let's get B over C. So B, sorry, let's get the angle at C. So B plus C, or let me say, since it's a triangle, I'll say A angle CB. A angle CB is equal to B plus C, which is equal to, and B is 30 degrees plus, and then C 65 degrees, that's equal to 95 degrees. So A angle CB is equal to 95 degrees. Now, for us to get E, we're going to make use of the sine, or we're going to make use of either the sine or cosine rule, but let's look at the condition that is fulfilled. Now, for us to get the condition that is fulfilled, let's look at what we are looking for. The question says, calculate correct to one decimal place the distance of the shift from A. So this is the shift from A. So we are looking for the distance AC. And so AC, we need to know this angle. We need to know this angle in order for us to be able to use the sine rule, because it's only one side that is given to us. And since it's only one side that is given to us, we've known this angle. So this angle and this side is known. So we need to know this angle. Then we can use the sine rule to get this side. So for that, we need to compute the value of E. So how do we compute the value of E? Let's get this angle known. So this angle, let's call it, so my last letter here is G. So I'm going to call it here H. So H is equal to H. So H, first of all, H is equal to 94 degrees. Now H plus 94, rather, H plus 94 degrees is equal to 180 degrees. What's the reason? Sum of interior opposite angles. Remember that if from our diagram, sum of interior opposite angles, when I took in the other class, in the other lesson, when I mentioned the angles that are formed when a transverse across parallel lines, I said that this was the diagram I used, and then a transversal cutting through parallel lines. So if we have angle A and B, so both of them are interior on the same side, so A plus B is equal to 180 degrees. So this is the reason is they are interior opposite angles. So the sum of two interior opposite angles is equal to 180 degrees. Either you find them in this way, or you can, as in this case, you can have it like this, like this. So you have this as A and then you have this as B. They are sum of interior opposite angles. So H plus 94 degrees, so H is equal to 180 degrees minus 94 degrees. That will give you 180 minus 94. That's 86 degrees. So now for us to get E, we cannot say that everything here is angle at a point. So we say E plus say D plus E plus H plus E plus D plus 245 degrees equal to 360 degrees. Why? Angles at a point. Angles at a point. The next is to look for the value of E. So E is equal to 360 degrees minus H minus D minus 245 degrees. So have we gotten the value of D? Oh yes. So if we include 245 degrees, sorry, if this 245 degrees is from the north to this line, that means there will be no need for D. So but if we, so let me remove D in this equation, because 245 degrees is inclusive, so plus D, that's 245 degrees. And 245 degrees. So if we include D, that means from the north to the south is 180 degrees. That's what we're going to include. So take note of that. So let's go. So E is equal to 360 degrees minus H is what? Minus 86 degrees minus 245 degrees. So E is equal to 360 minus 86 minus 245, 29 degrees. So E is equal to 29 degrees. So we've done this side, we've done this angle, so we can get this side using the sine rule. So now let's use the number one, figure one, using the sine rule. Using the sine rule, you can say sine C, which is sine C, which will give us what sine C, A angle CB. A angle CB is called B plus C, which is 95 degrees sine 95 degrees equals to 15 equals to sine E, which is 29 degrees over AC. So AC is equal to 15 sine 29 degrees over 9 sine 95 degrees. So AC is equal to 15 sine 29 degrees. 15 sine 29 divided by sine 95. 7.2 7.2999. So I'm going to approximate to 7.30. So the question says we should correct our answer to one decimal place. So to one decimal place is okay. So that will give us AC approximately is equal to 7.3 kilometers. 7.3 kilometers to 1 dp. So that's the answer to number figure 1. Number 2 says how far east of A is C? So let's do that. Number figure 2. How far east of A is C? So east of A. So when you talk about east of A, it means from point A. If you move, go east. These are your compass. So in your compass, this is your eastern direction. So I'm going to use broken lines. Okay, so now east of A is C. So from the compass or the point at point C, move until you meet the line here. Okay, so this is what we have. So take note of what I did. East of A is C. So at point A, move east, and then let it meet this a line drawn from C. So this is the distance of A. This is the distance of A in the eastern direction from C. So that's what it implies. Then what you're going to do is that you discover that this is a triangle. So let's look at what we have here. We're going to have something like this, and then this is it. So this is a right angle triangle, and then this is your AC. So let's call it AC, and then this is what we're looking for. This is the distance we're looking for. Let's call it D. Okay, so now look at this. This east of A is east of A. Try to find the distance or how far east of A is. East of A is in respect to C. We can see that this angle is already inclined. This angle is already inclined to this line here. So we're going to make this a fit this angle. So and that angle is 30 degrees. B is 30 degrees. And then AC from our calculation is 7.30 kilometers. And then we are looking for AD. So we're going to say using one of the trig ratios. This is opposite and hypotenuse. So using the sine ratio, we're going to say sine 30 degrees. So 30 degrees is called opposite, which is AD of hypotenuse 7.00. So AD is equal to 7.00 sine 30 degrees. And AD is equal to 7.00 sine 30, 3.65. So AD is equal to 3.65. Okay, we're not told to correct this to one decimal place. So these are final answers. So let me also correct to one decimal place. So AD is approximately 0.7 kilometers to 1 dp. But you can leave it here in exam because you are not told to correct answer to one decimal place. Or you can put this then write this, come down and write AD is approximately 0.7 kilometers, then indicate by saying that you corrected the answer to one decimal place. So that is the answer to Roman figure 2. In the diagram, AB is equal to 8 kilometers, BC is equal to 13 kilometers. The bearing of A from B is 310 degrees, and the bearing of B from C is 230 degrees. Calculate correct to three significant figures: A, the distance AC; B, the bearing of C from A; and C, how far east of B C is. So let's work with this diagram. We have point A, and it's pointing this way. Then this is point C, and then on C we have this. We have this. And we have this. Okay. Now let's put what we have, what the information we're given. So AB, so this is point B. AB is 8 kilometers, and then DC, line DC is 13 kilometers. 13 kilometers, and this angle is equal to 50 degrees from what is going to say 50 degrees, and this angle here is 40 degrees. 40 degrees. Okay, so okay, let's work. So The bearing of A from B, the bearing of A from D would be from the north. The bearing of A from B from the north to this line, that's considered 10 degrees. Bearing of A from B is 310 degrees, and the bearing of B from C, the bearing of B from C is 230. So B from C, 230 degrees. Okay, now to here. So alright, so this is all we're given. So let's analyze our diagram, then we can begin to solve. So altogether we need to know here this angle. Since two sides are given to us, we need to know this angle, then we can use the cosine rule. But let's see if we can get this angle at this. So what we have here, for this angle, let's call it A, and this one let's call it B. And let's see. Okay, so let's call this angle C. Let's call it C. Alright, so A is equal to A will be okay, so our A will give us A plus 40 degrees equal to 90 degrees. Why? Complementary angles. So that means since this part is 40 degrees, from here to here would be the difference between 90 degrees and 40 degrees. So A is equal to 90 degrees minus 40 degrees, and A is equal to 50 degrees. A is 50 degrees. Then B is equal to 50 degrees. Why? Alternate angles. Since here is 50 degrees, by alternate angles, this part will be 50 degrees also, which is B. So now to get A angle BC, A angle BC is equal to 50 degrees. It's equal to BA plus B, A plus B. That will give us 50 degrees plus 50 degrees. That is also equal to 100 degrees. Okay, so with that we can calculate this. So okay, first okay, using cosine rule, we can use cosine rule to get AC, which is what question A says we should get, the distance AC. So we have one completed angle on two sides. So using the cosine rule, we need to have line AC squared is equal to 8 squared plus 13 squared minus 2. That's 8 times 13 times cos 100 degrees. That's 64 plus 169 minus 2 times 13 times 8 times cos 100. That is just minus 36 points. Minus 36 points. 1188. And this will be 64 plus 169. Minus times minus is plus 36.1188. And this will give you 64 plus 169 plus 36.1188. 269 points 1188. So line AC is equal to square root 269.1188, and then line AC is equal to square root 16 points 16.40. So how many significant figures to 3 significant figures? So therefore, line AC is equal to approximately 16.4 kilometers to 2 significant figures. You can see 0.40 because 0 is non-significant. So already in here it's already corrected to 3 significant figures. So I just decided to remove the 0 or to not include the 0. So that's for AC. Let's look at B. The bearing of C from A. The bearing of C from A. From A, that is going to be from the north to this line. The bearing of C from A, and what would that be? So the bearing of C from A would give us okay, let's see. Okay, so the bearing of C from A would give us B. The bearing of C from A would give us, so let's call the bearing of C from A, let's say it's alpha. It's equal to the bearing of C from A, which is alpha from A, is alpha equal to, so the bearing of C from A is equal to alpha equal to now I'm gonna, if you look at it, we don't have to look for this angle. We don't have to look for this angle, and we could, if we wanted to, in fact, we could have done that. We could have looked for this angle, and then since here is 40 degrees and here is A, we could get this angle and then just find out sum of angles on the straight line, because this is a straight line, and then alpha plus this angle plus this angle equals 180 degrees. Then we subtract, then we get alpha, or we can do it this way. We come here and we see that since this side is 50 degrees and this is C, from the south to this line is alternate to alpha, which is from the north to the line. So eventually we have something like this. So this is what we have. So we are looking at here. We want to get the value here, alpha, and we have here already, so none here. This part is known. So alpha plus beta, let's call this beta. They are alternate. So alpha is equal to beta. What's the reason? Alternate angles. And where beta is equal to C plus 50 degrees. C, which is the triangle angle A, angle CB, and then 50 degrees, which is from the north to this line. So from here to this place is alternate to from the north to this line. So alpha is, so let's say from here we can say C plus 50 degrees, because here I don't have beta, but C I have on the triangle, and here is 50 degrees. So let's get C. This is where we're going to make use of the sine rule. So using, in order to get C, we're going to use the sine rule. So using the sine rule, sine 100 degrees over, we've gotten AC 16.4 is equal to sine C. This is sine C over 8. So sine C is equal to 8 sine 100 degrees over 16.4, and then sine C is equal to 8 sine 100, that's 7.8785 divided by 16.4, 0.4804. So C is arc sine 0.4804, and C is equal to 0.4804, 28.7 degrees. So that's angle C, 28.7 degrees. And remember that we have to look for the value of C, because C is needed for us to be able to get the bearing of C from E. So I'm going to say the bearing of C from E, which is alpha, is equal to C plus 50 degrees and this is equal to where C is now 28.7 degrees plus 50 degrees, and that will give you 28.7 plus 50 as 78.7 degrees. So the next is C, and C says how far east of B is C. East of B, the east of B will be this B, east of it is east of B. So we want to know how far it is in respect to C. So both B and C, this is where they meet. East of B meets with the south of, to extend C down. So this is the from the north, the southward part of C, the southward direction of C meets east of B here. So we call this is another triangle. So we can see this triangle like this. Right. So this is, and let's call this, okay, this is B, C, and then this is called, let's see, T. And the first, our focus is here, this distance, how far east of B is C. So our focus is DT, which we have here. So now, what's this angle here? This inclined angle up. Okay, this angle is given to us, so we are going to, we'll make use of this angle. So this angle C is 50 degrees. Okay, and this line, which is BC, do we need the distance? BC 13 kilometers. This is 13. BC 13 kilometers. So what do we do? Using this is opposite hypotenuse, using this the sine ratio, sine 50 degrees is equal to BD over 13, and then BD is equal to 13 sine 50 degrees. BD is equal to 9.95, that's 9.959, and so let me come here and say, so B is approximately, is 10, okay, 9.96 kilometers to 3 significant figures, to 3 SF, to 3 significant figures. The bearings of points P and Q from A are 45 degrees and 120 degrees respectively. If the distance AP is 80 kilometers and AQ is 60 kilometers, calculate ABC. So let's get our bearings. Let's get our diagram. So the bearings of points P and Q from A. So A is our reference point. So since I'm going to have 120 degrees, 120 degrees will go this way, and 45 will go this way. So A, I'll put A at the middle, point A, 45 degrees. So wherever it stops, that's going to be point P. Point P. This is point P. And here will give me 45 degrees. And then from P, okay, so 8 kilometers, AQ is 50 kilometers. So, and then here 120 degrees. It's like this. This is Q. And so from the north to this line, that's, I'll put this angle, this particular angle here, that's 120 degrees. I didn't want to put it here because it will not look as if it's the angle between this line and this line, which is from the triangle APQ. That means angle A is now this 120 degrees, which it is not. This angle is from the north to this line, not from this line to this line. So let's take note of that. Okay, so then let's come over here, PQ. So AP is AP. Okay, if the distance AP is 80 kilometers, so AP 80 kilometers. This is given to us, and this distance gives us AQ is 50 kilometers. AQ is 50 kilometers. So A says the distance between P and Q. So of course we need to know these angles for us to be able to use the cosine rule to get this angle. But before we do that, let's first of all get the angles here. So let's call this angle A, and then let's see if we can get any other angle A, and angle A. So if this here, we can get this part. What about here? We're not giving any information, so we cannot get here for now. So okay, let's work with A. So angle A is equal to 1. So from here to here would be, that's 120 degrees minus 45 degrees. 45 degrees. So if from the north to this line is 45 degrees, and from the north to this line is 120 degrees, then from this line to this line would be the difference between 120 degrees and 45 degrees, and that would be A is equal to 120 minus 45 is 75 degrees. So using the cosine rule, using the cosine rule, so PQ squared by PQ squared and PQ squared is equal to 80 squared plus 50 squared minus 2 times 80 times 50 times cos 75 degrees. Cos 75 degrees. So 80 squared, 6,400. 50 squared, 2,500. 2,500 minus 2 times 80 times 50 times cos 75. That's 2070.55. So 6,400 plus 2,500 minus 2070.55. 6829.45. So PQ is equal to square root 6829.45. Line PQ is equal to square root 82.64. So how many significant figures? To 3 significant figures. So line PQ is approximated to 82.6 kilometers. So 3 significant figures. So that's the value for A and B. So this is the bearing of Q from P to the nearest degree. So we're going to get the bearing of Q, or we need to get the bearing of Q from P. So from P, we draw our line, our angle rather, from the north to meet the line that connects P and Q, that connects P to Q. Okay, so with that, or when this is done, we know that we need to know this angle from here, from the north to this line. So let's call this line, let's say it is B. Let's say it's B. And okay, let's see. So for us to be able to get this angle, we need another we need information, or we need to get something else for us to be able to get here. Then once we get it, we add this to 180 degrees, because from the north to the south is 180 degrees angle on a straight line. So when added to B, we get the bearing of Q from P. So let's see. Okay, so from here to here, that's from from the west, from the south to the west is also 40. So let's call this C. So let's see what that gives us. So from our diagram, so let's say from the diagram, not our, from the diagram, C is equal to 45 degrees. C is equal to 45 degrees. Why? Alternate. Okay. C is equal to, C is equal to 45 degrees. Why? Alternate angles. So this is alternate. So this is what this is alternate. So here you have O, 45 degrees, and then here you have C. So they are alternate. So from this line to, let's do this way. So from the south to this line, it's alternate. From the south to this line is alternate to, from the north to this line. So okay, so with that we can get B. So if C from the line to the north to the south is 45 degrees, then from the north to this line would be what? What would that be? So that would give us, we still need to get something for us to be able to get the value of B. So let's get this angle. Let's call it angle D. So once we get angle D, we can subtract this angle from this angle to get B, because C is the sum of D plus B. C is from this line to the south, B is from the south to this line, and angle D is from this line to this line. So the sum B and D will give us C. So let's get angle D. So we can do that using the sine rule. And then you have sine this, we know this angle A. What's A? A is 75 degrees, so sine 75 degrees over 82.64 is equal to sine D over sine D over 50. So sine D. So instead of using sine D, sine D is equal to 50 sine 75 degrees over 82.64. So let me just calculate that, because of whenever we are representing from our sine rule, we always use upper case of letters to represent angles and lower case to represent sides. So 50 sine 75 divided by 82.64, that's 0 points. So sine D is equal to 0.5844, and D is equal to arc sine 0.5844. D is equal to 0.5844, 35.76 degrees. So now we've gotten this angle, which is from this line to this line. So we're going to say since C is equal to D plus B, so for us to get B is equal to C minus D. So angle B, which is this angle here, is equal to angle C is 30. What's our C? We said C is alternate, so it's 45 degrees. 45 degrees minus 35 degrees, 35.76 degrees. So what's B? B is equal to 45 minus 35.76. That will give us 9.24 degrees. So B is equal to 9.24 degrees. So therefore, the bearing of Q from P, bearing of Q from P is, so the bearing of Q from P is, so if we call it okay, I'm using, it's equal to 180 degrees plus 9.24. That will give us 189.24 degrees. That's the bearing of Q from P. So it says how far east of A is Q. East of E will give us from the A, the eastern direction is, okay, so let it meet with this direction here. So this will give us this triangle. So since it's A and Q, let's call this R. So let me rewrite this. Let me draw it here. So we have something like this. So this is it, and then this is right angle triangle R E Q. So east of A is this direction. So I'm looking for AR. So now we need to have an angle. So let's get this angle here. Let's call this my last letter, or the last letter I used was D. So let me call this angle E. Now we couldn't use, we could, but this angle from A to this line, from this line to angle A is 75 degrees, but let's just look for another angle since we have to look this angle. But I think we know this angle to be better. So from here, from the north, okay, so E, so let me call here F. So what is F? Okay. Since from A here we have from the north to this line, so give us 120 degrees, and from this line to the south, the sum of those two angles will give us some angles on a straight line. So we have A here, so this is A, and we have this 120 degrees, and here is F. So this angles on a straight line. So F plus 120 degrees equals to 180 degrees. What's the reason? Angles on a straight line. So angles on the line. That's the reason. So F is equal to 180 degrees minus 120 degrees. That's equal to 60 degrees. So how does that relate to E? F is equal to E. F is equal to E, and that's equal to 60 degrees. Why? Alternate angles. So if that is true, then that means this angle here is 60 degrees. Now this AQ from the diagram, AQ is 50 kilometers. So let's put it here, 50 kilometers. So, and we're looking for AR. So opposite of hypotenuse is what? Sine. So using the sine ratio, we're going to have sine 60 degrees is equal to, sine 60 degrees is equal to opposite, which is AR over 50, and AR is equal to 50 sine 60 degrees. AR is equal to 50 sine 60, 43. AR is equal to 50 sine 60, 43.30. So that since it's distance, I'm going to get my figures correct to approximately 3.3 kilometers. two significant figures. So those there is no significant here. So can leave it like this, or as it is already correct to three significant figures. So that is the answer. 3 points PQ and R are on a horizontal plane. Point PQ is on a bearing 120 degrees at a distance 80 meters from point P. Point R is on a bearing 0.45 degrees and a distance of 150 meters from point Q. 3 points P, Q, and R are on a horizontal plane. Point Q is on a bearing 120 degrees at a distance 80 meters from point P. So 120 meters from point P. This should be point P. 120 meters. So this is Q. Point Q. So this is point Q. So from here to here is 120 degrees. And then the distance is 80 meters. 80 meters. And then from there, point R is on a bearing of 0.45 degrees and a distance of 150 meters from point Q. So 0.45 degrees from point Q is going to be like this. And the distance is 150 meters, so it's going to be longer. Yes, like this. So from here, we're going to draw a line. Okay, like this. Alright, this is what we're going to have. So this is point R, and so 45 degrees. 45 degrees will be here. 45 degrees. Like this. 45 degrees as the angle, and then the distance between Q and R is 150 meters. 150 meters. So this is the bare information I was giving to you. So let's complete it. So we need to know his angle from that. So let's call this angle B, and let's call here E. And then so we say A. So A is equal to A plus 120 degrees is equal to 180 degrees. This is raising angles on a straight line. Using a straight line, so A is equal to 180 degrees minus 120 degrees, and A is equal to 180 minus 120, so that's 60 degrees. So B is equal to A because it's 60 degrees. Why? Alternate angles. So B is equal to 60 degrees. So altogether, so P angle QR, the angle triangle PQR, angle Q is equal to B plus 50 degrees. That is equal to B 60 degrees plus 50 degrees. That will give us 110 degrees. So now we're going to look for PR. Question is A, remember figure 1 under A says the distance between point P and R. So this fulfills the cosine rule condition. So A1 using the cosine rule, I'm going to have P line PR squared is equal to 80 squared plus 150 squared minus 2 times 80 times 150 times cos 110 degrees. And this will give us 80 squared 6,400 plus 150 squared 22,500 minus 2 times 80 times 150 times cos 110 minus 8208.48, and this will give you 6,400 plus 2,500 minus 99 is plus 8208.48, and that will give us 6,400 plus 2,500 plus 8208.48, 37,108.48. So line PR is equal to square root 37,108.48. Line PR is equal to 192.64. We have to correct our answers to two significant figures. This will give us PR, so therefore line PR approximately to two significant figures. This is the first, this is the second. So that was 190 kilometers to two significant figures. So option number figure 2, the bearing of point P from point R. The bearing of point P from point R. Point P from point R. So point P from bearing of point P from R would be like this. Okay, so we need to know this angle. Let's call here. Let's call this R. Okay, angle R. And then we need to know here. Of course, from here we can get it. So let's say if A, B, C. So we say the bearing of P from R is that will give us, that's equal to is 180 degrees. So let's say is let's call the bearing itself. Let's say is beta. Beta is equal to 180 degrees plus C plus R. So C is equal to 45 degrees. Why? Alternate angles. Now to get R, we're going to use sine rule. Using the sine rule, so we're going to say sine 110 degrees over 192.64 is equal to sine R over 80. So sine R is equal to 80 sine 110 degrees over 192.64. So sine R is equal to 80 sine 110 divided by 192.4. 80 sine 110 divided by 192.4, 0.3907. So R is equal to arc sine 0.3907. R is equal to 0.3907. 22.998 degrees. Of course, our angle cannot be like this, so that will give us 23 degrees approximately to the nearest degree. To the nearest degree. So that's R. Now, so let me say, therefore beta, which is the bearing of P from Q is equal to 180 degrees. 180 degrees from the north to the south plus C plus R. That's equal to 180 degrees plus, what is C? C is 45 degrees. Then plus R is 23 degrees. Simply, that would give us 180 plus 45 plus 23, 248. 248 degrees. That's for the. I noticed that the angle given to us here is 45 degrees. Yes, so 45 degrees. Where is it? Okay. Distance of 45 degrees, but mistakenly I use 50 degrees here. P angle QR is equal to B plus 50 degrees equal to B plus 45, and I've used it in the calculation. So answer here. So, and when I got here, I use this angle here, so there's discrepancy. So I'm going to change it to 50 for the sake of the fact that I've already used 50 here. So please pardon me. So I'm going to change this to 50 degrees, because 60 plus 50 will give me 110. So for that reason, I'm also going to change it here also. Where is it? 50. Okay. This is an exam. Don't change any figure. Use what is given to you. I'm doing this because I've already calculated with 50 and I didn't do it intentionally. So I'm going to correct the answer here. So since it's 50 degrees, therefore my final answer will be 50 degrees also. So this is giving 50 degrees. 50 degrees. So let me get my answer again. One eighty plus 50 plus 23. That will give you 253. 253 degrees. Final answer. Okay, so B says how far west of R is Q to 2 decimal places. How far west of R? So R, the west is this. So when you say west of a particular, either east of, so anywhere the other points mentioned can meet that destination, that's the triangle that will be formed. So west of R, how far west of R? So we talk about west of R. So you go to your compass, your cardinal points, and you draw a line to meet west of R is what is Q, so R and Q. So if this is R and this is where Q is, according to our drawing, this is Q. So west of R, then this is Q. So let Q meet R in this line such that form the right angle triangle. So if you bring Q here to form, it will not coincide because this is west. So west naturally, so that it form 90 degrees. So west naturally meets Q from if Q is going northward. So this will be 90 degrees, and then you join 2 points together, it forms the right angle triangle. So how far west of R is Q? So west of R, so let me bring this up. Okay, so this is it. So this will be my angle, my shape. So I'm going to call this, we have PQR. So let's say this is C. So I'm going to draw my shape. So this is what I'm going to have. So this is C, and this is R, and this is Q. So in between this triangle, triangle PQCR, triangle QCR, you're going to have here as 50 degrees, and of course we are looking for this distance. How far west of R? So we are looking for this distance CR, and then this QR is 150 meters. 150 meters, and that will give us, so in triangle QCR, using, since we're looking for CR opposite to hypotenuse, using the sine ratio. using the sine ratio, we're going to have sine 50 degrees is equal to opposite TR over hypotenuse 150. So TR is equal to 150 sine 50 degrees. So line TR is equal to 150 sine 50, 104.91, and we have to correct our answer to how many decimal places? To 2. So that's just okay. So that is 9067, and that's the full figure. So 114. So 2 decimal places, the first, the second, so the third, make it 0. The turns to 0, add 1 to this, becomes 114.91 kilometers to 2 decimal places. C says find the perpendicular distance from Q to line PR to 2 decimal places. From Q, perpendicular distance from Q to line PR. So perpendicular distance means from Q, this straight line, to line PR. So line PR, where this straight line meets line PR, let's call it M. So this is line PR. So from M, it's now become MR. So we have this triangle like this, and then this is the perpendicular distance, and then meeting this point. So this is R, angle R. So and this is Q. So we have here 50 degrees, and here we have 60 degrees. R, angle R is what? Angle R, I'm going to look for R. Sine R is 23 degrees, approximately 23 degrees. We have here, so QOR will give us, so QM, this is M, and then this is R. So this line is 150 meters, and then which other? So what we have here, QPR is the whole distance from P to R. So this M is from here to here. So we don't know this from here to here. We don't know it, but that's, I think, what are we looking for? We are looking for find the perpendicular distance. So we are looking for this side. Okay. So for us to know this, we're going to use the sine rule. So sine rule, since we are looking for this side, we need to know this angle so that we're going to have a known angle on the side, and then a known angle on the unknown side to compare with. So for us to get here, we say from triangle QMR, angle M. So angle M is equal to 180 degrees minus 50 degrees plus 23 degrees. Why is this so? Sum of angles in a triangle, so this is equal to 180 degrees minus 50 plus 23 degrees will give us 50 plus 23, 73 minus 73, so that's 180 degrees minus 73, that's 107 degrees. So therefore angle M is equal to 107 degrees. Okay, so now we are looking for NQ. So we're going to say using the sine rule. Using the sine rule, we need to have sine 107 degrees over 150 is equal to sine 23 degrees over MQ. So line MQ is equal to 150 sine 23 degrees over sine 107 degrees. Line MQ is equal to 150 sine 23 divided by sine 107, 61.28 what NQ is equal to 61.29 kilometers to 2 dp. So these are final answer. 61.29 kilometers. Two cyclists A and B leave the town C at the same time. Cyclist A speeds at the rate of 5 kilometers per hour on a bearing of 0.49 degrees and B at the rate of 9 kilometers per hour on a bearing of 275 degrees. After 2 hours, calculate A, B, and C. What I mean by A, B, and C, I mean the questions that's associated with A, B, and C. So let's get our distance. So for cyclist A, distance covered by cyclist A is equal to distance is speed times time, and that is equal to speed is 9 kilometers. So first the speed is 5 times 2, that's equal to 10 kilometers. Distance covered by cyclist is equal to 9 times 2, that's equal to 18 kilometers. So let's get this information in a diagram form. So two cyclists A and B. This cyclist A speeds at the rate of 5 meters per hour on a bearing of 0.49 degrees. So this A, from this is the starting point, so let's call it O. So this will give us 0.49 degrees. And cyclist B at the rate of 9 kilometers per hour on a bearing of 275 degrees. 275 degrees will be on the side, so I'm going to draw my diagram again. Since 275 degrees will be this way, so the diagram will come this way. So cyclist E on a bearing of 0.49 degrees, so this is O. 0.49 degrees, and then B 275 degrees. So this distance is 10 kilometers, and this one is, and then this is cyclist. This is A, and then this is B. And then we join. So 10 kilometers and O, B will give us 18 kilometers. And now we're told that this is from this point, this is not. Okay, so this point to this line is 275 degrees. This point O. So 275 degrees. Now, so this is the information we got from this information. But for us to be able to calculate or get the answers to these questions, we need to analyze this information and then complete it. Then we can be able to use it to solve these questions. So first thing, we need to get this angle, because this obviously is going to fulfill the cosine condition and create the angle on two sides. Alright, so let's get this angle. So let's call here E. The angle E will give us E is equal to or is E plus 275 degrees is equal to 260 degrees. Why? Angles at a point, and then giving E is equal to 260 degrees minus 275 degrees. So E is equal to 85 degrees. Then B angle OE, which is this angle here, is equal to E plus 49 degrees. That will give you 85 plus 49, 134 degrees. 134 degrees. So A, using the cosine rule, AB, line AB squared is equal to 18 squared plus 10 squared minus 2 times 18 times 10 times cos 134 degrees. And this will give me 18 squared 324 plus 100 minus 2 times 18 times 10 times cos 134 plus 134 minus 250 and 250.077. This will give you 324 plus 100 plus 250.077. And this will give me 324 plus 100 plus 250.077. 674.077. So line A equals the square root 674.077. So line AB equals to square root, and we're told to correct the answer to the nearest kilometer. So 25.96. So line AB approximately equal to 26 kilometers to the nearest kilometers. B, the bearing of B from A. So the bearing of B from A like this. So if here's A, this is B, and then we need to know angle A. Angle A. So the bearing of B from E is, let's call it alpha. Is alpha equals to from the north to the south is 180 degrees. 80 degrees plus B and then plus E. But B is equal to 49 degrees. Why? Alternate angles. So using the sine rule to get A, using the sine rule, sine 134 degrees over 25.96 is equal to sine E over 18 plus sine E is equal to 18 sine 134 degrees over 25.96 sine E is equal to 18 sine 134 divided by 25.96, 0.4988. So E is equal to arc sine 0.4988, and E is equal to 29.92 degrees. And we're supposed to get the value to the nearest degree. So this will give me E is approximately 23 degrees to the nearest degree. So 23. So this is not our final answer. Okay, then anyway, let's go. So the bearing of B from A will then become, so let me see, I can use, let me complete it here. So let me bring this one closer. I'm going to say the reason here is angles at A point. So I can use here. So the bearing of A, so the bearing of E, the bearing of B, rather from E, that is alpha, that is alpha is equal to 180 degrees plus B plus E. Plus E, and that is equal to 180 degrees plus B is 49, then plus E. E is equal to 29.92. E is equal to 29.92 degrees. Okay, so that will give me, we could use 22 also, but most times I prefer the exact value rather than the approximated value in calculations. And sometimes it's advisable to use the exact value gotten for calculations rather than the approximated value. So 180 degrees plus 49 plus 29.92, that will give us 258.92 degrees. So alpha is equal to, so the nearest degree, so alpha is equal to 259 degrees. So the nearest degree. So approximations should be done at the final stage of the calculation. So if you observe carefully, we're not told to approximate this to the nearest degree because our focus, we're not intending to stop at getting the value of sine A. The reason why we got sine A was because we wanted to get the bearing of B from A, of which we needed to get the value of A first. So this value may not really be significant. We may not really use the approximated value here. Rather, we have to use this one. But even if we use this, the answer will still have been 259 degrees. So let's get to the last part. C. The speed at which A will get to B in 4 hours. Speed is equal to distance over time. So the speed at which A will get to B in 4 hours will be the distance between A and B over the time given. So the distance between A and B is equal to as AB squared 25.96 over time, which is 4 hours. And that is equal to 25.96 divided by 4, 6.49 hours. Or we can say this is equal to 6 hours. 0.49 times 60. 0 hours 29 minutes. So what I did here was 0.49 times 60 to get 29.4. So approximate to the nearest minutes, that's approximately 29 minutes. So it's 6.49 hours or 6 hours 29 minutes. This is supposed to be for time. This is speed, so it's going to be kilometers per hour. Sorry about that. So this one is not necessary. So we're not told to calculate time. It's speed, so it's supposed to be 6.49 kilometers per hour. So that's the final answer. A cyclist on training cycles for 4 hours at an average speed of 2 kilometers per hour from a point P and a bearing of 135 degrees to another point C, then to another point X, 12 kilometers on a bearing of 060 degrees. Calculate the distance px correct to 2 decimal places. So solution, this is the distance, the distance covered, covered by the cyclist from point P to Z, from point P to Z, B, D, B, D. So D is equal to speed times time. That's equal to average speed 2 times time, which is what's our time? 2 kilometers per hour. Then to another point, cycles of 4 hours. That equals to 8 kilometers. Okay, so now let's get our bearing. So from a point P on a bearing of 135 degrees, so P from P 135 degrees, P cycles at an average speed of 2 kilometers from a point P on a bearing of 135 degrees to another point Z. This is point Z. This is 135 degrees. And then from Z, 12 kilometers away, so here is 8 kilometers. So from Z, on a bearing of 060 degrees, 060 degrees. So, and this distance is 12 kilometers. 12 kilometers. And then, okay, 60 degrees. That's cool. 60 degrees. So we're going to join these 2 points. So Px, this is point X. So what we're going to look for is this distance. Calculate the distance Px correct to 2 decimal places. Now for us to do that, we need to complete our triangle PXZ. So let's call here E. Let's call here B. So say B is equal to, or say B plus 135 degrees is equal to 180 degrees. Y. Sum of angles on a line. I will say supplementary angles. So this equals 180 degrees minus 135 degrees. B is equal to 180 minus 135, 45 degrees. B is equal to 45 degrees. A is equal to B, equal to 45 degrees. Y, alternate angles. Therefore, P angle Z X is equal to E plus 60 degrees. That will give us 45 degrees plus 60 degrees, which is equal to 105 degrees. 105 degrees. So we know this angle. So this fulfills the cosine rule. We're using the cosine rule. Px line Px squared is equal to 8 squared plus 12 squared minus 2 times 8 times 12 times cos 105 degrees. 64 plus 144 minus 2 times 8 times 12 times cos 105 minus 49.69. 64 plus 144, 208 minus x minus x plus 49.69. 208 plus 49.69, 257.69, and that will give me, okay, so line Px equal to square root of 2 37.69. So line PX is equal to 16.0527. We're told to get an answer correct to 2 decimal places. So 16 points. This is first, second. The third one is not up to 5, so we round it down. So it becomes 0.5 kilometers to 2 GP.